The barrage had barely stopped when the M4 high-speed tractor came thundering through the smoke, tracks chewing up the churned ground like it was late for its own war. It didn't look fast, but it had one job: drag America's heaviest artillery out of places no truck dared linger. Its straight-six Continental engine delivered a low-end pull that felt less like horsepower and more like stubborn defiance. It was the only vehicle that behaved as if enemy fire was just bad weather. Without it, the guns simply wouldn't move. They knew the war was getting heavier long before the artillery pieces did. The guns kept growing, the distances kept stretching, and the roads, if you could call them that, kept dissolving into a miserable blend of ruts and hope. America's expanding firepower had outpaced its ability to move it, and every commander could see the bottleneck forming like a storm bank on the horizon. Without a machine built expressly for hauling the new generation of long-barreled, steel-hungry artillery, entire operations would slow to a crawl. The existing tractors, converted trucks, farm machines on borrowed time, and half-tracks living lives they were never meant for, couldn't keep up. Their engines overheated under towing strain, suspensions buckled on broken ground, and rubber tires tore open like wet paper under sudden shell impacts. The need wasn't abstract or hypothetical. It was measured in minutes lost, guns stranded, and ammunition that simply couldn't reach the line. When the Army Ordnance Corps analysed the situation in late 1942, they reached an unsettling conclusion. None of their current towing vehicles had the stability needed to pull a fully loaded 155mm long tom across saturated terrain. Nor did they have a drivetrain designed to maintain traction while handling the weight transfer of a heavy artillery tongue bouncing behind them. The war was changing, and the Americans were suddenly short of a machine that could change with it. The need sharpened even further at ports like Cherbourg, where artillery was arriving faster than it could be deployed inland. Dock officers wrote reports describing guns that waited days for a suitable tow vehicle, the backlog stretching down the quays like a steel traffic jam. Even worse, the guns that did move often required 2 or 3 existing vehicles working in improvised tandem just to create enough torque. It was here that the Army identified a fresh requirement: a tractor with a robust track-based undercarriage, but without the excess weight and armour of a full-size tank chassis. A machine that could handle steep gradients without gear hunting, maintain traction in mud without carving itself into a trench, and tow massive artillery with a stability profile tested for lateral loads. And so the case for a purpose-built high-speed artillery tractor hardened into certainty. Someone joked that the Army needed a tow truck with the attitude of a bar-fighting bulldozer, and everyone quietly agreed. The M4 high-speed tractor was no longer optional, it was inevitable, and the war would not wait for it. The vision for the M4 high-speed tractor didn't begin with a sketch on a drafting board. It began with an argument inside the Ordnance Department. Engineers wanted a compact tracked hauler with proper suspension geometry, while logistics officers demanded something that could be maintained by any farmhand turned mechanic. At the same time, artillery commanders pleaded for a machine that would arrive when ordered, regardless of what the weather or terrain thought about it. In the end, the guiding doctrine was simple. America needed a tow vehicle with the discipline of a tank and the temperament of a workhorse. Rather than building an armoured platform and stripping it back, the designers approached the problem from the opposite end. They created a lightweight track chassis first, then reinforced it where physics insisted they must. The goal wasn't to survive direct fire, it was to outperform mud, gradients, and the stubborn inertia of artillery weighing upwards of 6 tons. One of the earliest breakthroughs was the decision to employ a vertical volute spring suspension system, a design proven on several American armoured vehicles but adapted here for a lighter load profile. This gave the tractor a smoother ride at towing speeds and allowed it to maintain track tension across uneven surfaces, reducing the risk of ground shock transferring into the towed gun's carriage. It was a stability solution disguised as comfort. Then came the interior requirements. The vehicle needed space for an entire gun crew, tools, ammunition, and the various essentials that made the difference between an artillery team arriving ready to fire or arriving ready to argue. This meant the cabin would be wide, squared, and unapologetically practical. With benches, stowage bins, and a simple layout, the crew could load, unload, and reposition equipment with minimal wasted energy, a small but significant advantage during rapid redeployments. Just as crucial was the mandate to ensure cooling capacity exceeded engine demand by a wide margin. Heavy towing generates heat spikes that can cripple an engine at the worst possible moment, so the Continental R6572's radiator system was designed with oversized fins and increased airflow. The engineers wanted absolute certainty that the engine would not cook itself halfway through a 155mm relocation run. Competing doctrines fought over details. Should the tractor prioritize top speed or towing torque? Should the cabin be fully enclosed? Should armor be considered at all? But the final design balanced these priorities with uncommon clarity. One engineer reportedly summarized it perfectly. "We're not building a hero. We're building the thing that gets the hero where it needs to be." What emerged was not glamorous, not elegant, but brilliantly aligned to its purpose. It was the tractor America needed, because the war's mobility demands had finally outgrown improvisation. The moment production orders arrived at Alice Chalmers, the tractor stopped being a theory and became an industrial puzzle with deadlines. Factories already stretched by wartime quotas had to create a machine that combined tank-style running gear with the serviceability of agricultural equipment. The production lines were noisy, fast, and occasionally optimistic. Steel shipments arrived late, casting batches ran hot, and the first prototypes revealed every flaw the drafting room had politely ignored. Machining the bogie assemblies became one of the build's defining challenges. Each unit had to maintain precise tolerances so the volute springs would compress and rebound smoothly under towing stress. Too loose, and the track would chatter itself to pieces. Too tight, and the suspension would lock under dynamic load, turning the tractor into a vibrating brick. Achieving that precision required new jigs, recalibrated milling routines, and a level of repeatability rare in wartime manufacturing. Then came the cab structure. Welders built the boxy body from rolled steel panels designed for speed rather than finesse. The squared geometry wasn't laziness. It ensured interior volume for crew, shells, and tools without driving production costs through the roof. Each weld line was tested for vibration tolerance because towing a 155mm long tom introduced shock forces that could warp or fracture a poorly laid bead. The cab may have looked blunt, but every edge followed a logic of efficiency. On the engine line, the Continental R6572-6 received particular scrutiny. Its cast-iron block had to handle persistent low RPM torque stress, far more punishing than conventional automotive use. Oil galleries were reamed clean, coolant channels were pressure-checked, and carburetors were calibrated specifically for heavy towing, not cruising. The engine wasn't built for excitement. It was built to drag a cannon uphill without complaint. Electrical systems were deceptively simple. A 6-volt layout, minimal wiring runs, rugged connectors, and mounting points chosen to avoid vibration-related failure. Wartime tractors didn't need elegance. They needed to start, run, and keep running when artillery crews were shouting at each other over incoming fire. Final assembly combined the parts into a machine that looked like someone had bolted a tool shed onto a tank chassis, and that was almost true. But as the components clicked together, a reliability emerged that wasn't apparent on paper. The tractor felt purposeful, dense with mechanical intent, ready for the kinds of jobs no truck wanted. And of course, factory testers had their opinions. One fitter remarked that the M4 looked like a filing cabinet, but pulled like a freight train, which the foreman considered unusually high praise. What rolled off the line wasn't flashy, but it was built like a machine that expected hard work and intended to deliver it. The first real trials of the M4 high-speed tractor didn't take place on a tidy proving ground. They unfolded on stretches of churned, unforgiving earth, chosen specifically to break lesser vehicles. Test crews climbed aboard with clipboards, wool coats, and the faint suspicion that the tractor would either impress them or attempt to launch them into a ditch. In the cold morning air, the straight-six engine fired with a steady metallic thrum, the kind of sound that promised torque rather than charm. What the engineers wanted most to see was behavior under load. They hitched a fully equipped 155mm long tom to the pintle hook, then sent the tractor crawling up slope grades designed to punish traction systems. The volute spring suspension performed better than anyone expected, distributing vertical force evenly while keeping the track shoes biting into the soil. It wasn't glamorous, but it was controlled, predictable, and mechanically honest. Field data showed something else as well. The tractor's centre of gravity sat just far enough forward to prevent the nose from lifting during steep towing angles. This meant the operator didn't have to fight the steering levers simply to maintain direction. The vehicle pulled like a committed draft horse, head down, grip tight, temper steady, even as the artillery carriage rattled behind it with all the enthusiasm of a trailer trying to escape. Weather trials brought new insights. In thick mud, the M4 maintained motion where wheeled tractors sank into helpless spirals. In snow, it kept a steady pace, because the track cleats dispersed weight wide and low. Even during hard braking on gravel, the chassis remained stable, proving that the engineers had correctly predicted how lateral loads would travel through the undercarriage. Crew feedback mattered just as much. Operators noted that the cabin layout made tool access quick. Everything had a place. Everything could be reached without acrobatics. The seating wasn't comfortable, but it was functional, and the visibility angles helped drivers judge towline behavior with surprising clarity. Small ergonomic victories often defined whether a machine became loved, tolerated, or despised in wartime, and the M4 stayed firmly in the respected category. Yet the tractor wasn't perfect. Heat soak during extended uphill pulls could push coolant temperatures close to their limits, prompting engineers to adjust airflow baffles and re-angle the fan blades for better draw. These tweaks transformed borderline moments into stable performance, proving the machine could be adapted without major redesign. Observers recorded that the M4 didn't accelerate quickly, didn't corner sharply, and didn't offer any excitement beyond the job it performed. But excitement wasn't the point. Dependability was. One test officer summed it up by saying the M4 could bore a hole through a hillside if you asked politely enough, which the engineers took as a triumph. The trials showed a tractor that wasn't trying to be impressive, it was trying to be indispensable, and it was succeeding. The breakthrough arrived not in a factory or proving ground, but in the winter chaos of the Ardennes, where mobility became a kind of currency. Roads vanished under ice, heavy guns froze into immobility, and logistics maps suddenly meant less than instinct. Yet the M4 high-speed tractor kept moving, its tracks finding grip where tyres became trapped liabilities. This was the moment the machine proved its purpose, not through drama, but through persistence. The tractor enabled a new rhythm of artillery deployment, allowing heavy pieces to leapfrog positions with an efficiency that hadn't been possible earlier in the war. It wasn't about speed, it was about certainty. When an army knew its guns would arrive, it could plan boldly. When it doubted them, every decision shrank. The M4 altered that calculus, giving commanders the confidence to reposition 155mm and 8-inch guns across terrain that had previously been dismissed as impassable. The design also revealed an unexpected advantage during recovery operations. Battlefields littered with damaged equipment often required rapid extraction, and the M4, with its consistent torque curve and low ground pressure, excelled at pulling wrecked vehicles or captured guns away from the front. Its towing capacity extended beyond its intended mission, transforming it into a multi-role asset without any formal redesign. Another breakthrough appeared in ammunition logistics. The spacious rear cabin and mounting brackets allowed crews to carry shells, fuse boxes, and essential tools alongside towing operations. This cut reload times dramatically because gun teams no longer waited for separate supply vehicles to catch up. The tractor had become a compact logistics hub on tracks, unadvertised but extremely effective. There were failures too, though none of them catastrophic. The cooling system, despite being oversized on paper, occasionally flirted with overheating during prolonged low-gear hauls in hot climates. Engineers addressed the issue by modifying shroud geometry and adjusting radiator fin spacing, improving airflow under strain. The brake drums also had a habit of collecting debris during wet operations, prompting field modifications involving simple cover plates shaped from scrap steel. Despite these imperfections, the tractor's overall performance marked a decisive shift in artillery mobility. It made the extraordinary seem routine, towing heavy guns through mud that swallowed jeeps whole, crossing ground scoured by shell fire, powering over gradients that intimidated trucks, and doing it all with a mechanical steadiness that demanded attention rather than applause. The breakthrough wasn't theatrical, it was structural. The M4 succeeded because it treated every obstacle as a technical problem and quietly solved it one track length at a time. With this attitude, it reshaped how American artillery operated in the final phases of the war, becoming a backbone rather than a support act. Long after the noise of the European theatre faded, the M4's influence continued to shape decisions that had nothing to do with towing guns. The tractor introduced a new expectation into American logistics, mobility as a form of resilience. When heavy weapons could be redeployed almost as quickly as infantry, planners began to treat artillery not as fixed assets, but as maneuverable fire platforms. This shift echoed through post-war doctrine in ways that stretched far beyond the tractor itself. The hidden consequence began with infrastructure. Roads damaged by shell fire or never built at all were no longer strategic choke points, because the M4 made off-road movement normal rather than exceptional. That reliability encouraged a different kind of operational thinking, one that assumed equipment could be repositioned rapidly in response to changing threats. In a quiet way, this reshaped how US engineers assessed terrain, how maps were drafted, and how supply routes were prioritized. Economically, the tractor's production had an unexpected ripple effect. Manufacturers who had specialized in agricultural machinery suddenly gained expertise in military-grade tracked systems. Alice Chalmers, in particular, found itself with skilled welders, machinists, and foremen who had spent years solving mobility problems under pressure. When the war ended, many of these workers carried that knowledge back into peacetime industries, accelerating advances in construction equipment, forestry machines, and mining vehicles. The wartime tractor had seeded a generation of civilian innovation. There was also a diplomatic dimension. Countries receiving American surplus equipment discovered that the M4 offered a level of adaptability rarely seen in military vehicles. The tractor served in environments ranging from Pakistan's rocky northern regions to humid tropical foothills, proving versatile without extensive modification. Its presence helped strengthen early post-war partnerships by demonstrating that American equipment could operate reliably in climates where other vehicles faltered. Practical performance often achieved more trust than political speeches. Another hidden effect appeared inside artillery units themselves. The tractor enabled crews to work with a confidence that transformed their workflows. When repositioning heavy guns no longer felt like an ordeal, teams spent more time on calibration, bore maintenance, and fire discipline. The improvement wasn't glamorous, but it mattered. Faster relocation meant more opportunities for counter-battery action, more chances to fire from favorable terrain, and fewer instances where a gun stayed silent simply because it physically couldn't move. Even parades and public demonstrations carried their own quiet legacy. The M4 rolled through post-war streets around the world, its squared frame and purposeful tracks offering civilians an introduction to the machinery that had quietly shaped Allied firepower. These displays symbolized not aggression, but capability, a reminder that behind every artillery barrage had been a machine designed to ensure the guns always had a voice. The true consequence of the M4 was not that it moved heavy weapons, it was that it changed expectations. In a world used to vehicles with long lists of excuses, the tractor behaved like one that simply refused to offer any. Its legacy carried forward not through heroism, but through the understanding that mobility, done properly, could be a strategic force in its own right. When the war finally closed its iron pages, the M4 high-speed tractor didn't fade into retirement. It simply found new jobs waiting for it. Armies around the world realized that a tracked hauler with reliable torque and a generous interior didn't stop being useful just because the front lines vanished. From training grounds to border posts, the tractor continued its work with the same unbothered steadiness that had defined it during the conflict. Its post-war career highlighted a truth often overlooked in military design. A machine built around fundamentals tends to outlive the era that created it. The M4's engine architecture, for example, proved adaptable to different fuels and climates with minimal alteration. Its robust cooling system handled tropical heat, while its track pressure suited sandy, rocky or marshy terrain with equal competence. This flexibility meant the tractor served everywhere from European farmland to the Brazilian interior, long after more specialized vehicles had retired themselves through complexity. Engineers studying the design in the late 1940s began to identify patterns that would guide future support vehicles. The combination of a low-slung chassis, predictable center of gravity, and wide track stance offered a stability template that influenced later earth movers and engineering tractors. The M4 had shown that a vehicle didn't need armor or advanced hydraulics to excel. It needed geometry that respected physics and components placed where maintenance crews could reach them without dismantling half the machine. Its internal layout also left a mark. The concept of integrating crew seating, tool storage, and ammunition brackets into a single transport platform resurfaced in post-war towing vehicles, self-propelled guns, and even early missile handling equipment. A small cabin that doubled as a workspace proved invaluable in operations where time dictated success much more than comfort. Collectors and restorers later discovered that the tractor's simplicity was its greatest gift. The straight-six engine was forgiving, the suspension used durable springs rather than exotic parts, and the cab design invited refurbishment rather than intimidation. As a result, numerous M4s survived decades of varied service, each carrying layers of history in soot, dents, and the unmistakable hum of a machine that had earned its confidence honestly. The legacy extended into civilian industries as well. Forestry operations valued the tractor for its traction on wet slopes. Construction crews admired its ability to drag equipment across soft ground. Rural engineers found it dependable for tasks that defeated lighter vehicles. The M4 had slipped into civilian life without demanding praise or ceremony. Work first, recognition optional. Ultimately, the tractor's influence endured not because it performed spectacular feats, but because it demonstrated how engineering clarity leads to longevity. The M4 didn't chase innovation. It simply got the fundamentals right with a persistence that outlived the war that created it. In doing so, it left a quiet but unmistakable imprint on the generations of machinery that followed, proving that utility, when done well, becomes a kind of legacy all its own. A machine like the M4 high-speed tractor doesn't announce its significance. It leaves it behind in the marks it pressed into the ground. Those parallel tracks, cut across Europe, Asia, and the Americas, form an unbroken record of a vehicle that treated difficult terrain as nothing more than a technical detail waiting to be answered. In a world still recovering from conflict, that attitude carried a quiet message about how progress is made. Steadily, deliberately, and without theatrics. The tractor's squared silhouette invites a kind of reflection rarely granted to wartime machinery. It is neither imposing nor decorative, but its shape tells a story of priorities: straight lines for simpler fabrication, wide stance for stability, generous interior space because people and tools needed to fit without compromise. The geometry is so direct that it becomes almost philosophical, a reminder that function, when executed precisely, becomes its own kind of beauty. A closer look at its undercarriage reveals another lesson. Every component sits where maintenance hands can actually reach it. This isn't a convenience. It is a philosophy that shaped later generations of support vehicles. Accessibility reduces downtime, and downtime was the enemy of artillery mobility. By solving this practical problem, the M4 nudged military engineering toward a mindset that valued sustainment as much as performance. The tractor's persistence after the war also offers perspective. Many vehicles born in wartime burn brightly and vanish quickly, their relevance tied to the conflict that required them. Yet the M4 endured because its utility was not circumstantial. It answered universal problems that existed before, during, and after battle. Heavy loads, difficult ground, long distances, and limited infrastructure remain challenges in every era, and the tractor proved that well-considered mechanical logic can bridge those decades with ease. Still, the most revealing insight comes from the way the tractor interacts with its environment. Where some machines impose themselves on the landscape, the M4 works with it. Low center of gravity for slopes, wide tracks for soft earth, cooling designed for slow, sustained labor rather than bursts of speed. It behaves like a machine that studied the terrain before deciding how to cross it, and that restraint feels almost modern in its sensibility. And as the years stretch on, the tractor's legacy sharpens into a simple truth. The M4 shows that engineering doesn't need spectacle to matter. It needs consistency, clarity, and the humility to solve the problems that don't make headlines. In that sense, the tractor becomes more than a piece of wartime hardware. It becomes a reminder that the quiet solutions, the ones that simply work, are often the foundations upon which larger victories rest. The historical record makes it plain. Wherever artillery needed to move, despite the landscape's objections, the M4 made the journey possible. It remains a factual cornerstone of mid-century mobility, a machine whose influence can still be traced in the design principles of modern military and industrial haulers.